Good morning. Have you ever wished you could see the future? Some of you might say yes, but for that you would need a crystal ball. But in the business world, you don't need any crystal ball. All you need is a predictive analytics. So, ICS Rakesh Chawla welcome you all in our deep dive into chapter 7. Today, we are going to learn how business uses historical data to anticipate the trends and make smarter decisions. So, what exactly is predictive analytics? It is a branch of analytics that uses historical data, statistical method, and some tools to learn and predict about the future outcomes. Imagine a retail company which is trying to guess next month's sale. The reason: it needs inventory to build, it needs workforce, it needs the probable expenditure that it has to incur, and therefore has to maintain some amount of cash flows. So instead of guessing, they will use the data from the previous years. They took the data of the sale, promotion, advertisement expenditure, and holidays to plan their business operations. That is the predictive analytics in action. Let us start with the term forecasting. It simply means you are estimating the future values based on the past and the present data. There are few common ways to do this thing. First is the regression analysis. In the regression analysis, we will take two variables and assume one variable is dependent on the other variable. So for example, if we take sales as variable X and advertisement expenditure as variable Y, we can say my sales would be dependent on advertisement expenditure. Therefore, my variable X is dependent on variable Y. So we have to predict the estimated value of X, that is sales, based on a advertisement expenditure that is planned, which is the variable Y. So what we are doing? Essentially, we are trying to estimate the regression equation of X on Y. On the other hand, if I assume my variable Y is dependent on variable X, so let us say my variable Y is the amount of expenses I would spend on the entertainment, and the variable Y is the income that I am getting on a regular basis. So in this scenario, the variable Y would be dependent on variable X, and we have to find out the regression equation of Y on X. Another method of doing the forecasting is the trend analysis, which will look into the long-term patterns over a period of time, sometimes 5 years, 10 years. So this will give you a smoothing kind of thing. It will tell you the trend in your business. In this, one of the most important method is the method of moving averages. So let us start with the term regression. We will do theoretical portion. We will try to understand what actually regression analytics means. Try to solve one or two simple examples and then go into the Excel sheets. Similarly, we will do moving averages method theory. Try to understand the concept, how it is being calculated. Do one or two practical questions and then go into the Excel. So let's begin. So let us start with the regression analysis. So basically, in regression, there is a need to estimate the value of one variable. For making this estimate, the statistical tool which is being employed is the regression analysis. So we can say, so first of all, we are discussing about regression analysis. Now we can say that regression analysis is a statistical model. So it is a statistical model which describes the relationship, rather it describes the mathematical relationship. Mathematical relationship between two or more variables. Now, if we are saying that there are only two variables and the relationship has to be established between only these two variables, then it is a case of simple regression. But if there are more variables, more than two variables, then it might be the case of partial regression or multiple regression. But for the scope of this chapter, we will be discussing only simple regression. The partial and multiple regression will come into picture at a later stage. Now, in this case, we are assuming there are two variables, variable x and variable y. Remember, you have to first of all assume the dependency among these two variables. So what does the term dependency would mean? You have to make an assumption that whether the variable x is a dependent variable. So if x is a dependent variable and its value is being affected by the value of y, I am repeating, the value of x is being affected, being dependent on the value of y, which is assumed to be an independent variable. So in this situation, we are trying to find out the regression equation of x on y. That is, x is dependent on variable y. Whereas, if our assumption is that the variable y is dependent variable, that is, its value is being dependent on the variable x, which is an independent variable. So that would mean we are trying to have a regression equation of y on x. This is the most important thing in this particular topic. Now, I will give you one example. Let us say you have assumed that variable x is a expenses on entertainment that you will be doing, and variable y is your income of the month. So it is obvious that the variable x is dependent on the level of your income. So we can say the variable x is dependent and variable y is independent variable. On the other hand, so in this case, what we have to calculate? We have to find out x on y. But if you are taking x as the sales revenue, or rather you can say x as the advertisement expenditure being incurred by the company, and y is the sales revenue generated. So we can assume that sales revenue is being dependent on the advertisement expenditure that is being incurred. So this is the independent variable. And in this scenario, we have to find out the regression equation of y on x. Now, basically, first of all, understood what the regression equation is. So let us say we have taken the value of x and y for the last 10 years. This might be any figure. If we are plotting these pairs of values over a graph showing x here and y here, so it might be possible that these pairs would be like this one. Now, if we are planning that, okay, in the future, my value of x will be this one. For the next year, I am assuming value of x will likely to be here. So can you tell me what will be my estimated value of x? From the scatter plot, it is clear that both the variables are moving in the upward direction. But to find out the exact value of y1, we have to apply the regression equation. So with the help of regression equation, we would be able to plot a line between these two variables. So this line might be, say, this one. So we can say with reasonable accuracy that if the regression line is red line and I am planning to have a x1 amount of expenditure in the next year, so I can safely assume that the level of y would be this one, y1. But here is a catch. What would be happened if, let us say, someone else has put a line like this one? So say the line is someone had put the line like a blue line. So in that scenario, my estimation for y would be a significant increase in the estimated level. Now this is a dangerous situation for a business because a lot of decision has to be made on the basis of estimation. So whenever you are taking a decision, you will try to have as accurate as possible. Your estimation should be, to the extent possible, close to the reality. Now, how to ensure that? For that thing, we will use the method of least square. So what we will do, let me just first remove this line. So what we will do, we will try to have the difference between the line and the actual value in the past. This difference should be minimum. So if the difference between the actual figure and the estimated line is being taken, we will always try to have least square. The square of these differences should be, when squared, should be minimum. And that is why this method is known as the method of least square. So how to find out the regression equation using this method? So let us first try with the equation of x on y. Now the regression equation of x on y is being denoted as x is equal to a plus by. Now what does this a and b would mean? So in this equation, the term a shows the intercept. So in the previous diagram, the regression equation, which is being denoted by the red line, would be touching the x-axis at this stage. So this will be termed as point A. It shows that if the value of y is 0, how much will be the value of x? Then B shows the slope of the regression equation. Now, this slope means if there is a change in value of x, let us suppose value of y reduces by this much amount. So how much reduction would we expect in the variable x? So this slope, change in y and change in x, would be denoted by the term b. This b is also known as the regression coefficient. And since we are talking about the regression equation of x on y, that is, we will write here x is dependent on y. So we would use the term at a later stage, not at this time, but at a later stage, we will write this b as b subscript xy. So remember, whenever I am saying bxy, that would mean this is the regression coefficient or slope for the line x on y. Now the question arises, what would happen if the regression equation is not x on y, but rather y on x? So this would mean that variable y is dependent on variable x. So in this situation, the line will be y is equal to a plus bx. Now, again, A would represent the intercept, B will be the slope or regression coefficient. But to differentiate between earlier B and this B, we would be using the term at a later stage as B subscript yx. So what does it mean? It means regression coefficient of the regression line y on x. Now the next question is how you are going to find out the value of A and B. It is one thing to say that it is intercept and B is the slope, but you have to find out the numerical figure. So for that we will be using, I will first explain x on y. So for this thing we will be using, let us use this blue pen, two normal equations. Two normal equations will be solved to find out the value of A and B. So these equations are sigma x is equal to NA plus B sigma y and sigma xy is equal to A sigma y plus B sigma y square. Now what does it mean? I will explain one by one. Sigma x would mean sum total of variable x. Sigma y will be sum total of variable y. Sigma xy again sum total, but now you have to multiply variable x with y and then find out the total. Similarly, sigma x square is the sum total of x square. First you have to square the x value and then find out the total. Similarly, for sigma y square is the sum total of y square. Similarly, for the equation y on x, we will be using two regression equations, two normal equations, that is sigma y is equal to NA plus B sigma x, sigma xy is equal to A sigma x plus B sigma x square. Now the normal question is, it is kind of appear to mathematics and I am not that much good in mathematics. It is a general observation of the students that they are not well versed with the mathematical terms. But afraid not, we will not use this much kind of mathematics. It is a simple, you just have to remember two equations. But once you will do a numerical question, you will easily be able to understand what does it mean. So we will try to solve one numerical question first. So let us suppose the variable x, which was say your expenditure on entertainment, is being given. And variable y, which is your income level, is also being given. So let us say your income is 50,000, 60,000, 40,000, 50,000 and 80,000. We will take just 5 figures. Now, your expenditure, which is a portion of your income, is say 10, 5, 15, 20, 12, and let us say 25. So make it something else. I will just try to make it rounding offs for the calculation purpose. So this will be, sorry, we will make it 0. So make it 20 also, no issue in that. So 25 plus 15, in this case total will be 0, 4, 6, 8, 80. So my sigma x is 80. My sigma y, total of y column, is 6, 4, 200 and 180. So you can either write 180, yes, you can write 180 also, no issue in that. Now we have to find out x square, y square and xy. So we will use calculator for later on calculations. First of all, it is simple, tan square. We will just square this x-axis to find out x square. So tan square will be 100. 15 square will be 225. Let me just check to be double sure. Yes, it's 225. Then 400, 400 and 625. So if we'll just check the total of this figure, so this comes to sigma x square. So that will be 100 plus 225 plus 800 plus 625. So it comes to 1750. Then for y square, this will be 2500, 3600, 1600, 2500 and 6400. So total will be sigma y square is equal to 2500 plus 3600 plus 2500 plus 6400. So this comes to 15,000. Then for xy, this will be 10 into 50, 500. 50 into 60, 900. 800, 1000 and 2000. So the total will be sigma xy. So this comes to 3000 plus 800 plus 900 plus 500. So this comes to 5200. We would also need it the n. N is the number of pairs. So the total number of pairs is 1, 2, 3, 4, 5. Total 5 pairs are being given. Now we have to make an assumption that whether x variable is dependent on y or y variable is dependent on x. So we can clearly see that expenditure would depend upon the level of income. So we can say in this case x is a dependent variable and y is a independent variable. So in effect, we have to find out the equation of x on y. Remember, our equation of x on y is x is equal to a plus by. So we can say equation will be x is equal to a plus by. But the problem is we have to find out a and b. And to find out these values of a and b, what we have to do? we have to use the normal equations. These equations has to be used. So we will say sigma x is equal to NA plus B sigma y. This is the first equation. Then sigma xy is equal to A sigma x plus, A sigma y, not x. A sigma y plus B sigma y square. So these figures can be taken from here. First we need the sigma x, which is 80. Then n was 5. B we have to find out. A and B both have to be find out. Sigma y we have calculated is 180. Sigma xy is calculated, it is 5200. A have to be find out. Sigma y is 180 and sigma y square is 15,000. So putting these figures in the equation, sigma x is equal to 80. So 80 is equal to 5a, n was 5, plus b sigma y. Sigma y was 180. So this will be my first equation. Second equation is sigma xy, which comes to 5200, is equal to a sigma y 180y 180a plus b sigma y square. So my y square is 15,000 b. Now I hope you all know how to solve the linear equation. So we will multiply this thing with one common factor. So 180 by 5, it comes to 36, and this by 1. So 36 into 80, it comes to 2880 is equal to 36 into 5, it will be 180a plus 180 into 36, it comes to 6480b. The second equation was 5200 180a plus 15,000b. It was 15,000b. So just putting a negative sign. Now this 180a is cancelled out. 6480 minus 15,000. So it comes to 0 minus 8520b. On the left hand side, we will be having 5200 and 2880 will be reduced. So minus 2320. So this equation becomes minus 2320 is equal to minus 8520b. Cancelling out minus sign. So the value of b comes out to be 2320 divided by 8520. So 8520 is being divided. So the value will be 0.272. Now this is the regression coefficient. Similarly, you have find out the value of b. What you will do now? Put this value of b into one of the equation. So let us say I am using this equation to find out the value of a. So what we will write? We will say 80 is equal to 5a plus 180b. Now the value of b is available. So we will put the value of b, which is 0.272. Remember, if you take the approximation, so your final answer would also be in approximation, but that is okay. So it comes to 80 is equal to 5a plus 48.96. So this would mean 5a is equal to 80 minus 48.96. So it comes to 31.04. So my a will be 31.04 divided by 5. So this will be 6.208, or you can say 6.21, rounding off. So that would mean my regression equation of x on y will be x is equal to, it will be x is equal to a plus by, which is x is equal to 6.21 plus 0.272y. Now, let us say in the question it is being given that in 2026 the income will be, income that is variable y will be rupees 100,000. So you have to find out the value of expenditure, entertainment expenditure that the person would do. So indirectly it is saying you have to find out the value of x. Now we all know x is equal to 6.21 regression equation 0.272y. So that would mean x is equal to 6.21 plus 0.272 and y is 100,000 being given. So this would mean 6.21 plus 27.20. So that would mean entertainment expenditure would be 33.41 thousand. So you can see with the help of regression equation we would be able to find out the estimated value of one variable based on the value of other variable is being given, and we are using the regression equations. But another question is, what would happen if we are assuming in the above question, let us suppose we are assuming that y is dependent on x. I am taking the same question, but now we are assuming that y is dependent on x. So what we will do, we will just copy this data, whole data. I am just copying it and putting this data here. But remember, there is a slight difference that now we have assumed that y is dependent on x. So regression equation will be y is equal to a plus bx. To find out the value of a and b, we have to use the two normal equations, which are sigma y is equal to na plus b sigma x, and sigma xy is equal to a sigma x plus b sigma x square. Now sigma y is 180, n is 5, a we have to find out, sigma x is 80, b. Similarly, sigma xy is 5200, A sigma x would mean 80A plus B sigma x square. Sigma x square is 1750. Again, solving these equations would mean multiply the first equation with 16 and the second equation by 1. So 180 multiplied by 16, it comes to 2880 is equal to 80A plus 80 into 16, 1280B. Similarly, 5200 is equal to 80A plus 1750B. Putting a negative sign, so 80A is cancelled out. This would mean 0 minus 472, and on the left hand side 2880 minus 5200, so minus 2320. So this would mean that B is equal to 2320 divided by 472. So this comes to 4.92 approximately. Now put this value of B in the first equation. So 180 is equal to 5A plus 80B. Now B is 4.92, so we can say 180 is equal to 5A plus 80 into 4.92. So 4.92 multiplied by 80, it comes to 393. So 180 is equal to 5A plus 393.6. So that would mean 5A is equal to 180 minus 393.60. So this will be 213.6 upon 5 is equal to A. So the value of A will be, negative sign will be there, minus 42.72. So that would mean the regression equation in this situation will be y is equal to minus 42.72 plus 4.92x. This will be my regression equation of y on x. Now, the two regression equation. Now this equation will be used to estimate the value of y. So let us say the question says estimate value of y if x is being given as, let us say, 100. So in this scenario, y is equal to minus 42.72 plus 4.92 within bracket 100. That would mean minus 42.72 plus 492. So the value of y comes to 449.28. This will be your estimated value of y. Now, some interesting fact about the regression coefficients. So first of all, let us write the regression equations simultaneously. So my first regression equation is on x on y and second is y on x. So my y on x equation was y is equal to minus 42.72 plus 4.92x. This was regression equation of y of x. And the regression equation of x on y, this one, it was 6.21 plus 0.272. 6.21 plus, rather we will do one thing, we will just copy that the figure, because sometimes we might make a mistake. So to avoid that mistake, what we are doing, we are just copying this thing and put this equation here. So this is my regression equation of x and y. Now, if I ask you what is the value of a in this, you will write 6.21. This is the intercept. Similarly, for y on x, it will be minus 42.72. But if I ask about you, what about bxy, regression coefficient of x on y? So this will be the regression coefficient. So 0.272. And what about the byx? So this will be 4.9. Now there are some interesting facts about the regression coefficients. So what are those facts? Just a minute. So what are the facts related to regression coefficients? First thing is, both regression coefficients will have similar sign. That is, both will be either positive or negative. It is not possible that both are having different sign. That is, one is positive and another is negative. Then you can see in our case also, both the bxy and the byx will have a positive sign. Second thing is, both regression coefficients bxy and byx cannot be greater than 1. If 1 is greater than 1, then other should be less than 1, so that product of both regression coefficient would be less than equal to 1. So in our case, bxy, let us check whether it is true or not. In our case, bxy comes to 0.272 and byx comes to 4.92. So it is less than 1, but it is greater than 1. Now multiply both these variables. So 4.92, 0.272 multiplied by 4.92 into 0.272. So in our case, regression coefficient is coming at 1.338. This is not possible. In our case, this comes only because we have assumed the data and applied this data reversely, meaning in the first case we have assumed that expenditure is dependent on income, but later on we have assumed that income is dependent on expenditure, which is not possible, and therefore in this particular situation we are getting this kind of thing. So in general you will not face this kind of situation. Then the third figure is that R is equal to, R is the correlation coefficient. So my correlation coefficient is equal to Bxy multiplied by Byx and under root of that. And fourth and last interesting thing is, if you calculate the R square value, it becomes coefficient of determination. This coefficient actually shows the explained variation in the dependent variable out of total variation. Higher the value of this R square, so let us suppose it is 0.94, 0.95, 0.98, that would mean the relationship between variable x and variable y is better, and the change in dependent variable could be explained through the change in independent variable. So R square is an important term. Remember this thing also. So these are the some important observations about the regression coefficient of x on y and y on x. The next part is to calculate the moving averages for getting a long-term prediction about the data. This long-term might be related to 5 years, 10 years, or might be related to 12 quarters, 15 quarters, 24 quarters, meaning 1 year or 2 years. So depending upon the data set, we have to calculate the moving averages. So let us move to the moving average part. Now let us start with the second component of the predictive analysis, that is the time series analysis. Now what is a time series? A time series is basically a sequence of observations of a random variable made periodically and placed in a chronological order. So that is, we can say a time series will be formed when the values are recorded at regular intervals of times. This interval of time could be monthly, quarterly, or annually. This time series will tell us about the general trend. It shows the variations over the period of time, and we have to analyze these variations. The time series, the four influencing factors could be included. These are called components of a time series. Components of a time series. These includes number 1, secular trend, cyclical variation, seasonal variations, and random variations. Seasonal variation is a general trend. It is also known as the secular trend. So this will show the long-term tendency. We can say this shows the long-term tendency of the observation. It might be upward, it might be downward, but it will tell about the overall increase or overall fall. Second thing is the cyclical variation. Now, cyclical variation means in general there are business cycles. So there might be some peak, then there will be some kind of a recession, then again recovery phase start, and then again a peak will be formed. So these cycles, business cycles, will repeat over a period of time. Sometimes in a metal industry, for example steel, these cycles would be of 2 to 3 years each, whereas in case of general businesses like travel, tourism, entertainment, where the discretionary spending is there, or car purchase, these cycles will occur over a period of months. So these cyclical observations will obtained because of business cycles or cyclical movement of the business. So these are being contributed by the business cycle nature of the particular industry we are talking about. Then there is a seasonal variations. These variations would occur within a period of 1 year. Within a period of 1 year. So for example, if due to seasonal variation like different climatic conditions, festivals, customs, holidays, these industries will be not noticeably affected by seasonal variations. Even festival like Diwali, Eid, Christmas cause the number of sale items to rise, especially the gift items. So these variations are occurred within a 1 year. Then there could be irregular or random variation. Irregular or random variation. These may be the one which are the result of certain identifiable causes, like there is a labor strike, there might be a flood or a drought, a severe winter, earthquake, an industrial accident, or something like that. These factors are purely unpredictable and it may influence the time series data either favorably or unfavorably. So these are called random variables or irregular variations. Now, to analyze the long-term secular trend, various methods can be used, and in this particular topic, we will talk about the method of moving average. So we all know what an average is. Average simply means a single figure representing the central tendency of the data. Now let us say we are calculating the average of 3 years, 4 years, whatever you want to take. Let us do this with the help of an example. So let us say there is a year and sales figure. Year is 2009, 2010, 11, 12, 13, 14, 15, 16, 17, 18, 19 and 2020. So the data for these years, last 12 years is being given. Now let us assume the sales are 280, 288, 266, 295, 302, 310, 303, 328, 309, 315, 320 and 332. We have to calculate the average of 3 years. So what we will do? We have to calculate 3 yearly moving average. I will come to the part of the moving average, but let us say we have to calculate the 3 yearly average. So what we will do? We will take the total of these three figures, the total of these 3 years, and divide it by 3. So let us do this thing. Let me open the calculator. Now 280 plus 288 plus 266. So the total comes to 834 and divided by 3. So it comes to 278. This is the simple average of first 3 years. Now what we will do? We will move to the next 3 years. So we will left 1 year and now we will consider the 3 year. Remember, in the case of 3 yearly moving average, the first figure will be blank. This figure, this 278 belongs to the year 2010. Similarly, for 266 for the next 3 years, what we will do? So what we will do? We will just calculate the average of next 3 years. So this will be 288 plus 266 plus 295. Total will be 849 divided by 3. So this comes to 283. So let me just some gap between the figures so that it will be more clear. So the next 3 items, now we will consider the next 3 items. So next three will be 266, 295 and 302. So the total will be 266, 295 plus 302. The total comes to 863 divided by 3 and we are getting 287.67. Then next three items will be considered. So 295 plus 302 plus 310. So this will be 907 divided by 3, 302.33. Similar fashion, next three. So this will be 302 plus 310 plus 303. 915 divided by 3, 305. For 2015, again next three, 310 plus 303 plus 328, 941 divided by 3, 313.67. 303 plus 328 plus 309. So the total comes to 940 by 3, 313.33. Next three, 328 plus 309 plus 315. This will be 952 divided by 3, 317.33. Then next three, 309 plus 315 plus 320. So 944 by 3 is the 314.67. Then 315, 320, 332 divided by 3, it comes to 967 divided by 3. So this will come to 322.33. So what does this moving average actually do? These moving average basically reduces the variation and gives you a clean data. So if I put this data, the similar data, in a graph, so it will be like this one. The actual data might come to like this one, which includes some kind of a variation. But the method of moving average, if I plot this data in the figure, this moving average data, this 3-yearly moving average data is being plotted in the same diagram, you might get a line which is more likely centered and provides you the overall trend. So if you look at this red line, the variations are being removed. So now let us do this part in the Excel itself. Okay, now let us try to do the regression equation in the Excel. So first of all, we would need two variables. So let us say the variable X shows advertisement expenditure in rupees 1000. and the variable y is showing sales again in rupees 1000. Now let us assume the management wants to estimate the level of sales if the advertisement expenditure is being given. So they are basically assuming that the variable y, which is sales, is a dependent variable, and variable x, which is a advertisement expenditure, is a independent variable. So basically the management is interested on finding the equation y on x. Remember, y on x equation is being given by y is equal to a plus b x, where a is the intercept and b is the slope of the equation. So let us say the data is being given 10, 12, 15, 18, 20, 24, 29, 37, 42 and 49. For the 10 years the data is being given. Now for sales, let us assume the data is 40, 42, 50, 55, 60, 67, 71, 78, 84 and 90. Let us make this 50. So this is the data that is being given for the basically 10 years, and we have to estimate the sales if the advertisement expenditure or the planned advertisement expenditure is being given. So let us say this data is being given for the year 2016, 2017 to 2025. Now the management is saying for the year 2026 we are assuming that my advertisement expenditure, which is being denoted by x variable, is this is the planned advertisement expenditure for the year 2026. Let us say its budget is 60,000. So what will be my estimated sales, which is being given by the y variable? So we have to find out this thing. So to find out the sales, basically what we would need the regression equation of y on x, which is being given as the y is equal to a plus bx. So first of all, we have to find out the intercept and slope. Now to find out the intercept value, so a, which is intercept, can be find out by using the formula intercept, bracket open, and we can just select the variable given in C2. So from C2 we will select up to C11, and for the given variable of x, it will be from B2 to B11, bracket close. So this gives me an intercept of 31.4734. So just to make thing easier, we will round it by using the round up function before the formula, bracket open, and how many digits we want the rounding up. So let us say it is 2 digit, bracket close, enter. So my intercept comes to 31.48. What does this 31.48 would mean? That is, even if my advertisement expenditure is 0, my sales revenue will be 31.48. Similarly, for B, we will use the function slope, bracket open. Again, for Y, we have selected the sales. For variable X, we have selected this B2 to B11, bracket close, enter. So this gives 1.25395. So what does this mean? Slope would mean that for every 1 rupee of advertisement expenditure spent, we were able to generate roughly 1.25 times of that advertisement expenditure, incremental advertisement expenditure. Again, we will use the rounding up function. So it will be round up, bracket open. For how many digits? Let us say for 2 digits. So that would mean my slope will be 1.26. So basically what we are trying to say is that the regression equation will be y is equal to 31.418 plus 1.26 x. This is my regression equation. Now naturally the question comes, how are we are going to use this regression equation? Remember, our original question was, if in the year 2026 the planned advertisement expenditure is say 60,000, so what would be my sales? So for that you have to put the regression equation now. Remember, don't write y is equal to. Instead, we will use the function is equal to 31.48 plus 1.26 multiplied by, instead of giving the x, we will give the reference of the cell in which x is being given. When we put the enter, so that would mean if we are spending 60,000 on advertisement expenditure, we could be able to generate a revenue of 1,07,800 rupees. So this gives you prediction about the future on the basis of which you can plan for the inventory, for the workforce that you will require, the amount of capital that would be needed. You can also plan about the logistic, about the sales point through which the sales are being generated. So all this planning can be done in advance if we could be able to find out the estimated sales. But remember, this is just an estimation. Actual figure might vary because in real life, sales would not only depend upon advertisement expenditure. There will be lot of variables. But for the simple regression, we will assume that there are only two variables, the variable x and the variable y. Now the question arises, can we do this thing graphically also? Can this regression equation be shown graphically also? The answer is yes. So what you have to do, you have to basically select the x and y variables. Remember, include the heading also. Go to the insert tab in your Excel. insert tab is being given. Select this insert tab. Go to the line chart and select the 2D line. Sorry, not line chart. Line chart would be used later on. Rather, we will go to the insert, use the scatter, and scatter is being given. Now, this scatter diagram shows that my data is actually moving into a positive direction. Now, this might be, you can say by chance, that line is kind of a smoothen out, but in general, this would not be like this one. So what we will do, we will have to add the trend line. So just right click on any data point. You just have to right click through the mouse. Then there are a lot of options will being given. So we will use add trend line. Now in the trend line, there are a lot of options. One option is exponential. So that would depend upon the type of linear regression we are assuming. If the regression is assumed to be linear, you will select linear regression. If it is logarithmic, exponential or polynomial, then the suitable option will be selected. Now, let us select the linear. Then, there are a lot of options. Logarithmic, automatic, custom. Then forecast is being given backward. Set intercept. Display equation on chart. Display R squared value on chart. So we will just put the right click. We will check the boxes for this. Now, if you can see in the chart also, we are getting some kind of equations. So I will just remove the check boxes. See, now there is just a straight trend line. But if we just put the check boxes of display equation on chart and display R squared value on chart, this equation and R square is also being given. Okay. Now, here you can see our trend equation is started with the first digit point and it ends up on the last digit point. So can we start the trend line from some else point? So let us say we are adding trend line. Again, we are going to back that thing. And let us say now we have put the regression equation is already there. Now we have set the intercept. Now this intercept would change the equation because now the linear equation will start through the 0. This will give you an idea about how much values are being distributed on the left hand side of the chart. But for the time being, let us untick this thing. Now, if you can see, the equation that we have got in our analysis was y is equal to 31.48 plus 1.26x. It can be written as y is equal to 1.26x plus 31.48, which is the same thing that is being given here. Also remember, the value of R square will tell you the percentage of the variation in the variable y, which is explained by the variation in the variable x. Higher the value of r square, the more coefficient of determination would be. So this is the regression equation on the graph. Now someone might ask that, sir, still in Excel we have to do a lot of things. So can this exercise be reduced? Yes, there is another way, but for that you will need the data analysis tool pack. So open the data tab in your Excel file, but you have to check whether the option of the data analysis tool pack is being shown or not. Sometimes it is not being shown in the Excel and you have to add this thing. So how to add the data analysis tool pack? You will just go to the file option, click on the file option, go to the option tab. In the option there is the add-ins, click on it. There is the analysis tool pack. You have to click on that analysis tool pack and then just press OK. Now remember, in my case the data analysis tool pack is already installed, so I do not press the OK. But when you press OK, it shows in the data tab. You only have to add this data tool once. If it is installed, then whenever you open the Excel, this tab will show. So I will just cancel this thing. Now this data analysis tab. How to use this data analysis? You just have to select the data, click on data analysis tab. There are a lot of calculations that can be done. It could be correlation, covariance, descriptive statistics, but we will use the regression tab. So select regression and just press OK. It will ask what will be your input range. So you have to provide the input range. So in the input range, I am selecting the y variable. You can also select the ranges by putting the values of the cell or by using the mouse. But if you want the heading also, so you just have to put the C1 to C11 cell. Then just click on the OK. It is asking for the X range. Again select OK. Then it will ask labels. Yes, I need the labels. Is my constant is 0? Confidence level is being used for the hypothesis testing. If you want the result on a new worksheet, just select this thing, else use the output range. So it will ask you what will be your output range. Select this cell and let us suppose I want the output in L1 cell. Then confidence level of 95% you could choose. It is up to you. So let us say I am choosing this thing. Then if I just press the OK, a table would be generated by which I could be easily able to calculate the equation. So just press OK and a summary table is being generated. So if you can see, the value of R square regression coefficient is being given. It is automatically being calculated. So this value 0.96035 is exactly similar as given in here. Then how to read this thing? The number of observation. There are 2-3 things that you have to use. The number of observation is being given as 10. Now, the next question is, what about the intercept? So, intercept is being given here, which is 31.4734. If you can go back and check, it was 31.4734. Ours is also 31.48. Now why it is 48? Because we have used the approximation or roundup function. Similarly, the slope was 1.254. So go here. In this case, the slope is also being given, which is 1.25395. So with Excel, a lot of time could be saved and you can easily show the regression equation as well as the scatter diagram. I hope this point is clear to all of you. Okay, so now let us start with the moving average method. Remember, we have discussed how to calculate the moving average. So if it is a 4-year moving average, what we will do? We will just take the average of the first 4 years and then we will move one cell downward and another cell is being added to calculate the average. So in general, the moving average is being used to smoothen out the variation or to get a longer term prediction. Those people who are aware of the stock market could recognize that there are 3 averages we are using to predict the stock prices in the future. These are 20 days moving average, 50 days moving average and 200 days moving average. So for the time being, we are focusing on 50 days moving average. But in essence, all the averages would mean the similar. So a 20 days moving average will consider the price of first 20 days, then move 1 year forward, leaving 1 year backward behind. So what we will do, we will just calculate the 50 days moving average. So in this case, the price of a particular stock or the various days, the closing price for the period 1st January 2024 up to 31st December 2025 is being given. So basically it is a 2-year time frame data for that particular stock price is being given. So what we will do, we will just insert the day. So this will be first day, second day, third day, and continuously we will number all these years. So since we have to calculate the 50 days moving average, so what we will do, we will go to the 50th day, this one, and calculate the average. So the formula will be AVRAGE, average, bracket open, from the cell C51 to C2. Remember, in the cell C1, the heading is being given. So that was the label cell. So this will be my average price for the first 50 days. Now if I move to downwards, now the formula is being changed from C251. Now I am including one more cell, that is C52, and leaving one cell in the above behind. So now the formula becomes C3 to C52. Similarly, for all the cells, I will calculate the moving average. Now what is the benefit of using this moving average? So for that, let me just show the diagram for the closing prices. So we will select all the closing prices of this particular stock, go to the insert tab, put the line chart, use 2D line. So this gave me, let me just increase the size of the chart so you will get a better picture. Okay, now this shows that prices are in general moving upward direction, but there is a fluctuation in the prices. So to get a better picture, what we will do, I will just remove this picture. Now I am including 50 DMA also. So that would mean now my chart will include three things. Number one, date. Number two, closing price. And number three, 50 days moving average. Going to the insert tab, using line chart, 2D lines. Now, if I just increase the size of the chart like this one, so you can see although the price fluctuation is there, but now the smoother line gives me a better clarity over the trend of this stock price. So in general, over last 2 years, the general trend of the stock price is to move upward. There might be some variation. Sometimes it is more than the average and other times it would be less than the average. But in general, the trend price is going upward. So with the help of moving averages, we can smoothen out the variation and get a more clear picture about the data. So I hope this thing is clear to all of you.